I just wanted to talk a little bit about electron configuration. This can be a confusing topic, and so I thought it'd be helpful for you to have the audio along with just the slides. So for electron configuration, really the periodic table is we're trying to figure out where electrons may be found in that vast empty space of the atom. And we know that as atoms add electrons, we add energy levels. And so our energy level is 1 for each period, numbers 1 through 7. And then when we get into that D block that we mentioned last class, there's a little drop in energy. So in the activity that you did today with the manager's code, you heard about the pink room and the sunny room, and you learned that like the pink room was slightly different in energy. An analogy for that might be like a split level. Like there's a step up or a step down in order to get to that floor, to a room on that floor. So this is basically just a little step down. And you'll need that for the overall pattern of when we are looking at electron configuration. So our energy level is like the floor. You're on the first floor, and that's the top of our periodic table, and then we just keep climbing stairs. More and more energy as we get further away from the nucleus. Once we're on the right floor, we can look at our sublevels. That's like a room. We have the S sublevel, that is the far left. That was the sunny room in our activity that had 1 bunk bed that could have 2 boarders. We have the P block, that's on the far right, and that's the pink room from the analogy with its 3 bunk beds and 6 boarders. And then our D block is the transition metals from groups 3 to 12, just that little sunken in part in the middle of the periodic table. And then the F block is on bottom. That is a room that would have 7 bunk beds with 14 boarders. We're really not going to worry too much about the F block in Gen Chem. Okay. And then, as I mentioned, the idea of the bunk bed, that is what is called an orbital. So each orbital can hold a max of 2 electrons. So the sunny room had 1 bunk bed. So the sunny room had 1 bunk bed that could hold 2 people. The pink room had 3 bunk beds, so it could hold 6 people. And if I look, 1, 2, 3, 4, 5, 6. And so because there were 3 bunk beds, I can hold 6. And we call that an orbital. So just to summarize, we have our floor. That is the energy level. What floor are you on? We then have the sublevel. What room are you in? Are you in the sunny room or the pink room? And then we have what bunk are you sleeping in? The bottom bunk or the top bunk? And so our numbers here, 2, 6, 10, 14, you can count those on the periodic table. So the S has 1 orbital, so it can hold 2 people. The P has 3 orbitals, so it can hold 6 people. The D has 5 orbitals, so it could hold 10 people. And the F has 7 orbitals, so it can hold 14 electrons in our analogy. So your activity today just looked at the S and P, but we could maybe have a dark room off the back that would have 5 bunk beds and could hold 10 people. So 5 orbitals that can hold 10 electrons. And when we talk about orbitals, we get these different shapes, these sublevels. So just as we go down the periodic table, the shapes get more complex. The room has to be able to hold all the bunk beds, and so the room gets a little bigger and more complex. So you do not need to memorize these shapes, just the names of the electrons, and you can just see that that pattern gets more and more complex as you go. You can also see here's a nucleus and then those outer rings with that fuzzy electron cloud border, and that ring is our energy level. So we can just keep adding energy levels as we go on the outside. So electron configuration is that manager code. It is a standard form that shows the number of electrons in each sublevel as a superscript or a power. So for example, helium has 2 electrons. So helium is in the 1s2 position. So what that means, it's on the first floor. It's in the first energy level. You can see that it's in period 1. That's where the big 1 comes from. The S, that stands for the sublevel, so that's the sunny room. So helium is the weird one, where the S is all the way over on the right. The first floor is full. Because the first floor is full, that is the noble gas stable configuration, and so it acts as a noble gas even though it only has 2. And then because there are 2 electrons, someone is on the bottom bunk and someone is on the top bunk. So there are 2 electrons in that sublevel. Here is a blank periodic table, and this is the pattern. I would advise you to pause the video here and color and label this periodic table as best you can so that you can add in the pattern as you go. So we have our energy levels 1 through 7. Don't forget about the little drop when you go to the D block. There's also a drop if you go to the F block. And then you can start the pattern that you see. So on our pattern, you first look at the floor. I'm on the first floor, the second floor. I'm in the first energy level. I'm in the second energy level. And then you look at what room you're in. That is the sublevel. So the S block is on the left, the P block is on the right, and the D block is in the middle. So you would fill in that if I am this element here, lithium, that I'm on the second energy level, in the first sublevel, that's the S, and then I'm the first electron. I'm the bottom bunk in the bunk bed. If we move next door to beryllium, okay, that's the second floor, still the first room, but now I'm the top bunk because I'm the second electron. If we move over to boron, okay, boron is still on the second floor. It's now in the pink bedroom. It's in a different room, so that is a different sublevel. It's the P sublevel, and it's the first electron. And this room has 3 orbitals, so it has 3 bunk beds, and it can hold 6 electrons. So we just count up 1, 2, 3, 4, 5, 6. Now every bunk bed is full. The orbitals are full, and we have to start over and go back to the third energy level. So again, pause here, take some time to fill in the pattern and fill in some of these blank patterns. You can see you've been given 4D1, 5D6. Can you figure out the pattern? Every element is unique and gets its own code for electron configuration. So take some time and can you figure out that pattern? And now, once we know that pattern, we can write that down. So electron configuration, you have to start at the beginning and fill in that manager's code. So boron has 5 electrons. 2 of the electrons are going to be in the first energy level. Remember, we have to fill the first floor first. So 1s2, first floor, sunny room, 2 electrons. Now I can move to the second floor. Second floor, first room, 2 electrons. And then in the second room on the second floor, the P sublevel, the P room, we can have 1 electron. So the total configuration is 1s2, 2s2, 2p1. Aluminum has 13 electrons, and so we want to put in 13 electrons. Again, we have to start at the beginning. The first floor has to fill first, 1s2. And then the second floor has to fill because aluminum is on the third floor. It's on the third energy level. So we have to fill in all of the second energy level. So 2s2, 2p6, and now we move to the third energy level. We have to go back to the S room, so 3s2. And now if I look, 2 plus 2 plus 6 is 10. plus 2 more is 12. And so I have 12 electrons. I need one more, and that is the pink room, 3p1. So 2, 2, 6, 2, 1, 13 matches 13. I am done with my electron configuration. Now let's try selenium. Selenium has 34 electrons. It's in the 4th row. So I have to start at the beginning, and I have to fill everything up from the beginning to the end. So remember that S can hold 2 electrons, P can hold 6, D can hold 10, F can hold 14. So selenium's in the 4th row. I need to fill up the 1st, 2nd, and 3rd row first. I always start at the beginning. So 1s2, 2s2, 2p6. Just like the aluminum, no differences there. Now, though, I have to keep filling in the 3rd row. So that is 3s2, 3p6. And now I can go into the 4th row. 4s2. Oh, and there's that step down, that weird little step down, 3d, 10. Now, if I add up all my electrons, I have 30. So I just have to place the last 4, and that is 4p4. And now I'm done. I've filled all the bunks with 34 electrons. I did it. Okay. Moment, pause the video, and can you fill out scandium, arsenic, and zinc? Remember to always start at the beginning, fill in each row one at a time, and then once your superscripts add up to the total number of electrons, you're done. Okay, and here are the results. 4s2, 3d1, as scandium is in the transition metal, so it's in that step down. Arsenic, all the way over at 33, so I need to fill in that configuration and end up with 4p3. And zinc perfectly fills that D sublevel, and we're done. So these are very tedious and long to do, and so our shorthand is called noble gas configuration. And what we do is we know that the noble gases are a complete shell, and it's the end of the pattern, and we have to start over. We know that that fills the floor, and we get to go to the next floor. So these are helpful to use. So the only options I have for noble gas configuration as the base of my shorthand are these elements: helium, neon, argon, krypton, xenon, radon. Once you pick the right noble gas, then you can add to it for the shorthand. So how do we do this? We use the noble gas found before the element. We need the last complete row, the last full floor before we have to move to the next one. We put the noble gas symbol in brackets, and then we write out the last incomplete energy level. So for example, chlorine has 17 electrons. So its standard configuration is written out. So the first energy level is filled. The second energy level is completely filled. The third is incomplete. So if we look at the second floor, that's the one before chlorine, that neon is the noble gas. So instead of writing out everything for neon, I'm just going to tell you it's neon and then add in anything that was incomplete. So the third floor isn't filled yet, so I'm going to put in as much of the third floor as I need to make this work. So neon has 10 electrons, plus 2 plus 5, that's 17, that matches. One more electron would fill the floor, but we don't need that one yet. Boron. Boron's a little silly because it is a short one, but it's a good example of how to do this. So there are 5 electrons. If we write out the full configuration, 1s2, 2s2, 2p1. So the only thing that's already filled is the first floor. So my noble gas that I want to pick is helium. It's my only option. And then I just fill in what's left over, 2s2, 2p1. For the calcium, it has 20 electrons. So when I look at my periodic table, argon has 18 electrons, and that's the noble gas that comes right before. And so all of those highlighted electrons just make argon. I don't even actually need to really write them out. I can just call it argon, and then all I need to do is fill in the fourth floor that hasn't been finished yet, 4s2. Okay. Go ahead. Scandium, arsenic, and zinc that you've already done. Can you pick out the correct noble gas? And can you fill in just the last pieces that you need? Again, you can pause the video here, try it on your own, and I'll reveal the answer in just a moment. Okay, so here we can see they're all argon because they're all in the fourth row, and I just have to fill in whatever's left over. I don't need the first 18 electrons, I just need the last 3 for scandium, the last 15 for arsenic, and then the last 12 for zinc. All right. Thanks for watching, and we'll practice this more next week.